Good morning, everyone. I'm going to deliver the lecture about tidal energies. Usually, we have two different categories of energies are available. One is renewable, another one is non-renewable energy resources. So, this tidal energy is a renewable energy resources. These are all the course objectives of the subject, and these are the textbooks and reference books are followed for the same. And in the tidal energy, we have some conditions here. We have some introduction parts in this. These are all the main content in tidal energies. Ocean energy potential compared with the wind and solar, and we have some characteristics about the waves and energy devices and the tidal energy technologies what we are going to adapt, and ocean thermal energies and osmotic powers. So today we are going to see some introduction part of the tidal energies, right? So first of all, we should know what is mean by ocean energy. The definition of ocean energy is nothing but it is a mainly renewable energy resource, mainly renewable energy. It can be obtained from sea and the oceans in the form of waves, tides, and thermal gradients, like a salinity differences also. So compared with the other two renewable energy sources, how ocean energy can be more advantages. So like some of the aspects, so our energy density, it is very high compared to the wind and solar energy. The availability condition also, it is a high continuous availability, and also it is predictable one compared to the other two. And the land requirement for this tidal energy, it can be very less. Wind and solar energy needed some larger space compared to the ocean energy. It is predictable because it is a high tide. We can get the high energy, high predictability, and that should be a moderate one in the form of the wind and solar energies. And then environmental impact, there is no compared to the other. Both wind, solar, and ocean are no environmental impact assessments. Then only that is why it is called as a renewable energy resources, right? So compared to other thing, this ocean is low environmental impact, and also the technology also developing for this ocean technology. Compared to others, it's only developing. So we have some criteria here. We have some, we should know some of the things here. So these are all the what is mean by wavelength, what is creased, what is trough, what are all the wave period, how it can be derived, wave frequency. So this is the direction of the travel. So this up and downs are there. There is a lower part of the wave, this is a higher part of the wave. So between the consecutive wave, this distance, the two upper, this distance is called wavelength. So that wavelength, the time required for this A and B is called the wave period. The highest part is called creased and the lowest part is called trough. The wave frequency also, number of wave creased passing through A and B. This is the frequency. So these are all the initial terms we have to know. So what does mean by wave height? It is a vertical distance between the creased and trough. So it determines energy content. Higher wave height, it will give more power. And wave period, I already told you, two successive creased. The time taken between the two successive creases is called the wave period, and the wavelength is horizontal distance between two creases. So it depends on the water depth and the wave period. Mostly it's depending these two conditions here. And the wave frequency is the number of waves are passing per second through the time, and the velocity also like that. So these are all the important wave characteristics, right? So the wave characteristics also, in the wave energy statistics, is the powers in waves proportional to the square of the wave height and also directly proportional to the wave period. This maximum wave energy we can get from some areas. This is North Atlantic and North Pacific and the southern oceans. These are all the wave energy maximum wave period. So this is the simple and explanations about the tidal energy, ocean energy, and this about ocean, the wavelength, period, height, and lower point of the wave. These are all the conditions. So initially, the tidal power, also called as the tidal energy, the form of hydropower which convert the energy tides into the usual form of the power, like mainly it will produce the electricity. So these tides are the wave caused due to the gravitational pull of the moon and the sun. That only the waves are creating. This ocean tides are the periodic rise and fall of ocean water level, occurs in twice in a each lunar day, right? We know all this. So during the one lunar day, the ocean water level rise twice and fall twice. So these are all the common factors. So in the time travel between this consecutive low tide and high tide is some hours. It takes the time is 6.207 hours. So the tidal range is difference between the consecutive high tide and low tide. What is meant by high tide and low tide? We know some factors here. What is the high tide is crest and trough. So this range is difference. The consecutive difference is tidal range. So during the high tide, the water flow into the dam, and during low tide, water flow out, which result moving the turbine. It will create the turbine moves. Although not yet widely used, the tidal power has potential for future electricity generations. These tides are most predictable than wind energy and the solar, and we already explained, right? So this is the tides. This both tides coming and going, it will be operated. The turbines and the generator can be operated. This tidal electricity generation works. The tides comes in and again when it goes out. These turbines driven by the power of the sea in the both directions. So we know the low tide and the high tide we can be seen, right? So this main part of the, so these are all about the tides, right? The tide power plants, compared to the tidal power plant, we have three categories. So first being the barrage itself. After that barrage, the barrage is mainly for holding the water back during high. The second part is sluice gate. It will let the through the third part. The third part consists of turbine and generator. Generate it resulting in electricity generations. So first one is, we already know there are three parts. And the first part is tidal barrage. This tidal barrage is a dam like structures. It used to capture the energy from masses of water moving in and out of the bay or river due to the tidal forces. So there is a tidal base. Next one is sluice gates. So it's left open during high tide and also it's closed during the low tide to create the water level differential. The differential creating potential difference that powers the turbine when the water is released. So it will be working like that. So tidal stream generator is mainly like as a wind generator. This will be producing this energy. Using this one type of energy is converted into the other type of energy. The tidal stream generator are very similar to the wind turbine, except the below the water surface instead of above water land surface. Likewise, there only the difference. The turbines and generator convert the movement of water coming from in the tide, and this is kind of kinetic energy. This energy converted into the electrical energy. So the same process also followed here. We have here two conditions here. One is single basin scheme, another one is double basin scheme. So what does mean by single and double means? So you can use the both sides, that's double, and one other only one, and then it is a single basin size. So in the double basin scheme, there are two basins on the land where. So in this in a single basin, it's only one basins are provided. One basins are kept in the only one side. So side the powerhouse located at the interconnecting waterway between the two basins. If we are providing the such structure in only one direction, the one side of the way means that is called a single basin scheme. Providing two sides, that waterway is connecting between the two sides, it is interconnecting waterway between the two basins, mean that is double basin schemes. The providing is a variation between the double and single. Finally, we'll move to the advantages of tidal energy. We know that what is meant by tidal and some of the factors we are using in the wave energy and waterways like that. So main advantages of tidal energy, it is an exhaustible sources of energy because there is no environmental pollution, there is no greenhouse gas emissions, there is no need of any fuels. As in our earth, 71% of the earth is covered by water. We all know that there is scope of generate this energy in a large scale. We can use this energy and we can producing more renewable energy sources while with using of this tidal power energy. Why? Because it's a 71% of resource energies are in this tidal energies. So efficiency of tidal power is far greater as compared to the coal, solar and wind energy, and also it will get the efficiency is around 80 percentage compared to the other energies. This tidal energy does not require any kind of fuel. There is no need of fuel to run this energy. This life of tidal energy also very long time process. There is no short time period. It will be a long time process, so we can get energy continuously. Then the large density of water, almost 1,000 times greater than in air. Compared to the air, it will be more high quantities compared to the density also. So results in very large amount of energies to get out the tidal current. If we speed is very low, if the speed is very low, we can get this. So these are all the main advantages of tidal energy. So once have advantage and also have some disadvantages, right? So only one major disadvantage is the cost of the construction is very high compared to the other constructional methods. Few ideal locations only adapting for this energy production, and it will affect some of the if it is the sea waves unpredictable. So we all know, if there are very high means it will damage the power generation units, and it will disturb the migration of the fishes. Actual generation is for a short period of time. The tides only happen twice a day, so we can get the electricity can produce only for that time alone. Usually the places where the tidal energy is produced are so far from the place where it is consumed. So the transmission of this energy also very expansive and also some difficulties. So these are all the major things in the disadvantages point of view. So these are the major tidal plants in our world. What is mean by this future scope in this? In a society nowadays, they are increasing about using the non-renewable compared to the non-renewable. Nowadays more moving to the renewable energy. So it becoming more and more important to have alternate source of power to keep with ever growing energy demand. The capacity of the tidal energy exceeds that of coal and oil, and it is renewable. The Department of Energy has shown great interest regarding tidal power as the perfect energy source for the future. We have to adapt some advanced construction methods, techniques, innovations in this energy. Then only we can get the more amount of energy from the tidal sources. Thank you so much. So these are all the course outcomes for this subject, especially for this wind energy, performance and applications, and the tidal energy, ocean energy technology, future prospects of tidal and thermal energy and osmotic systems. So thank you so much.